Section 6 has us looking at similarity transformations. We've talked about congruent transformations before, which were reflection, translation, and rotation. And now we're going to look at one other type of transformation, which is called a dilation, and that is a similarity transformation. And then we'll look at verifying similarity transformations on a coordinate plane to finish. So first off, this first word up here, again, was just to get you to understand what is a transformation, where we map one figure to a new figure. And the type of transformation that we're going to look at, I just stated, is a dilation. And a dilation is going to either enlarge or reduce the original figure proportionally. A dilation, we're going to say, is a type of similarity transformation. Within our similarity transformation, we're going to have a center of dilation. The center is your fixed point. We won't really get into that as much today. We will eventually talk about that more later on in chapter 9. But for now, just know that it's a fixed point where we're going to perform our dilation. And then we're going to have what we call a scale factor of our dilation. This is the ratio of the image, which is your new shape, over your pre-image, which is your old shape. So anytime I ask you for what is the scale factor, always think new over old. If you do your scale factor correctly, you'll come up with the correct scale factor that goes with an enlargement and a reduction. So we're going to identify whether our new shape is an enlargement or reduction. If you write enlargement, you should have a scale factor that's bigger than 1. And if you have a reduction, you should have a scale factor that is between 0 and 1. Right? So let's look at a couple examples. Letter A, determine whether the dilation from figure A to B is an enlargement or reduction. Then find the scale factor of the dilation. So if I'm going from A to B, I'm getting smaller, which means that it's a reduction. Remember, to find our scale factor, we're going to put the new shape over the old shape. You should be able to count some locations. So I'm going to put B over A. Looks like I have a half over here, a half over here. It gets me 1, 2, 3. Over, and we'll find its corresponding side length. 1, 2, 3, 4, 5, 6. 0 over 6 reduces to 1/2, which makes sense because we said that a reduction has a scale factor that is between 0 and 1. For letter B, again, we're going from A to B, which makes this an enlargement. Again, I'm going to put the new shape over the old shape. So I'm going to count this side length over here, which is 4. 1, 2, 3, 4. Over its corresponding side length on A, which is 3. And I'm just going to keep my fraction as is. I can't reduce 4/3, so I'm just going to leave it as a fraction of 4/3, which represents the scale factor.